Alright, so let's look at one more example putting everything together. So let's look at a radical one this time. So f of x equals x plus 1 to the 2/3 minus 2 power. So let's go ahead and find our derivatives, first and second derivatives, since we know we're going to need them. So f prime of x is just going to be equal to 2/3 times x plus 1 to the 2/3 minus 1, which is negative 1/3 power, and then times 1. So then that just gives us 2 over 3 times x plus 1 to the 1/3 power. And our second derivative, f double prime of x. So keeping in mind what this is. So then that's going to be 2/3 times negative 1/3. So negative 2/9 x plus 1 to the negative 1/3 minus 1. So negative 4/3 times the derivative of the inside function, which is 1. So we end up with negative 2 over 9 times x plus 1 to the positive 4/3 power in the denominator. So there's f prime, f double prime, since we know we're going to need them. Domain of this function, we know that's going to be negative infinity to infinity, since we're dealing with a cube root here. And then it's being squared after that, so we know we're not going to have any issues. So we're taking cube root of x plus 1, so no domain issues there. Alright, critical numbers. So we know f prime of x is going to equal to 0 whenever 2 is equal to 0, which doesn't make any sense, right? So we don't get any critical numbers that way. F prime is undefined whenever our denominator, 3 times x plus 1 to the 1/3 power, equals 0. So divide by 3 on both sides. X plus 1 to the 1/3 equals 0. Cube both sides. X plus 1 equals 0. So x equals negative 1. And it is in our domain, right? So the critical number is x equals negative 1 because it's in our domain. Alright, open intervals where it's increasing and decreasing. So looking on our number line. So we know our domain is negative infinity to infinity. And our critical number, the only one we have was x equals negative 1. So picking a number, let's look at x equal on negative infinity to negative 1. Let's let x equal negative 2. So then f prime of negative 2 is 2 over 3 times negative 2 plus 1 to the 1/3 power. And so 2 is positive. 3 is positive. Negative 2 plus 1 is negative. Cube root of a negative is negative. So we have positive divided by negative, so that's less than 0. So f is decreasing. And then on 1 to infinity, let's let x equal 0. So f prime of 0. Nice easy number. So 2 over 3 times 0 plus 1 to the 1/3 power. 2 is positive. 3 is positive. 0 plus 1 is going to be positive. To the 1/3 power is positive. So we have positive over positive greater than 0. So f is increasing. So f is decreasing. On negative infinity to negative 1. And f is increasing on negative 1 to infinity. Part D are open intervals where f is concave up, concave down. So now we're looking at the second derivative. So second derivative, f double prime of x equals to 0 would mean the numerator negative 2 equals 0. Doesn't make sense. We get nothing there. Undefined whenever the denominator 9 times x plus 1 to the 4/3 power equals 0. Divide by 9 on both sides, so x plus 1 to the 4/3 equals 0, and then raise both sides to the 3/4 power to undo the taking the 4/3 power. So we get x plus 1 equals 0, x equals -1 again. So same exact interval picture. Negative infinity to infinity is our domain. We're still splitting at -1. So then let's pick f double prime now of 2. Or sorry, -2. So pick x equals -2 as our test point again. Then the second derivative at -2 is going to be -2 over 9 times -2 plus 1 to the 4/3 power. So -2 is negative. -2 plus 1 is negative, but that doesn't matter because even after we take the cube root of it, that would be negative, but then we raise it to the 4th power, which makes it positive, and then times 9 is positive, so we have positive times positive in our denominator. Negative divided by positive is going to be negative, so less than 0. So f is, in this case, remember we're testing second derivative, so f is concave down. And then whenever on the interval -1 to infinity, let's choose x equaling 0 again, so f double prime of 0 is -2 over 9 times 0 plus 1 to the 4/3 power. So -2 is negative, 9 is positive, 0 plus 1 is positive, positive to the 4/3 power is positive. So that means this is less than 0, so f is concave down. So in this case, f is concave down on negative infinity to -1 union -1 to infinity. F is not concave up. Yes, you gotta tell me that it's not. Alright, next thing we want, relative extrema. So in this case we have to use first derivative test. Well, we could use second derivative test. But what happens if you plug in your critical number -1 into the second derivative? We already know second derivative is 0 there, so second derivative test would fail. You would have to use the first derivative test in this case. Well, luckily for us, we already have the work for the first derivative test. So we've already tested on both sides. We know it's changing from negative to positive, which then means that f has a what? F has a relative minimum. At -1, -1 f of 1, and in this case -1 f of -1. So that's going to be -1 comma, when you do the work, which I expect you to do, -2. And that was our only critical number, so it can't have a relative max or any other relative minima. So f has no relative max. Points of inflection. So the only possible point of inflection was x equals -1 again. And to be a point of concavity, it would have to change, but it's not. It's concave down on about -1, right? So no points of inflection because there is no concavity change. For the y-intercept, we need f of 0. So f of 0 is 0 plus 1 to the 2/3 power minus 2. 0 plus 1 is 1. 1 to any power is 1. So then 1 minus 2 is -1. So f of 0 is -1. So we know 0, -1 is our y-intercept. And now let's put everything together so that we can sketch our graph. So remember, label your axes, right? If you don't label your axes, what happens? Yeah, you lose points. Alright, so putting everything together, starting with our y-intercept. So our y-intercept we know is 0, -1. We had a relative minimum at -1, -2. So that's the only points we knew in this case right off the bat. So now f decreasing, -infinity to -1, and concave down. So decreasing concave down there. So it's going to look something like that. And then increasing on -1 to infinity, increasing concave down. Making sure you go through your intercepts. It's going to look something like that. And so there's your graph. So f of x equals x plus 1 to the 2/3 power minus 2. And that's what your graph's going to look like.